Okay, well, I know people are still coming in. That's absolutely fine, but we will get started now. So good morning, everyone, and welcome to the Friday of your conference. Well done for making it out of your warm beds and getting over here. I want to reassure you that we are the cool ones, not the ones that are still in their beds. Gold stars to us. We're great, okay? So this talk is going to be about the web and how the web got to where it is today. My name's Steve, and I work at Microsoft. I'm on the .NET team, and I think I've spent my entire professional career up until this point doing stuff related to the web. And I bet the web is a central part of many of your careers as well. Can you give me a hands up if you do stuff related to web technology? Yeah, I mean, it's like almost everyone, isn't it? Apologies to the small number of people who feel left out now. But, you know, I'm sure the web is important in your life as well. And it's a good area to work in because it's always changing. There's always something new to learn. We're always making it more and more complicated. And you might wonder, well, why is that? Why does it constantly change? Why is it always getting more and more complicated? Is this a good idea? Who's making these decisions? And are they making terrible mistakes? Well, that's what we're going to look at in this talk today. We're going to go through some of the history of how the web got to where it is today and think about where it might go next. Now, of course, like any history, it's a subjective story. It's just one person's opinion. It's not the objective truth. So it's a good chance that I won't cover everything. It's entirely possible that I'll miss out whatever you personally care about most. So if I do miss out something that you care about, please understand that is 100% deliberate. I've meticulously researched every person in this room so that I could systematically exclude everything that you most care about. Okay? You're welcome. All right, so let's get into this, shall we? Where would we start with the story of the web? I think the obvious place to start is with the invention of the web and our good friend, Sir Tim Berners-Lee. And I know most of you will know about him, you'll have heard about him, and you will know that he invented the web while he was working at CERN in Switzerland. But do you know why? Like, what was he actually trying to achieve? What did he think that he was doing at the time that he invented this, and how did it go? Well, the story goes a bit like this. So CERN is a very complicated place to work. They've got some pretty sophisticated projects going on, like literally building particle accelerators. So a lot to keep track of. And Berners-Lee kept track of his work in an electronic notebook system that he programmed himself. It was some software called Enquire. And it was a place that he could type in his notes. And he had one pretty cool feature in there, which is that he could link from one note to another. So you might be able to see where this is going, right? It's an early hypertext system that he'd created. And he liked it a lot. He thought it was brilliant and that everyone at CERN should be using this. He wanted to standardize on it. But he didn't just want everyone to use it independently. He wanted it to be all networked together so that everyone's notebooks could link to everyone else's notebooks and they could all see and edit each other's content. So he made this proposal, information management, and he published it in CERN. And you can read it today. It's a bit hard to make sense of a lot of it because a lot of it is quite specific to CERN. But there are some parts in here that you would recognize and understand. For example, this. In this diagram, he shows the idea of having a client browser, which is a multi-platform software, and it can connect to hypertext servers. And those servers can link to other hypertext servers. So that's very recognizable. He also, interestingly, had this idea that the hypertext wouldn't just be written by hand, but could be generated on the fly from database content. So he was coming up with this idea of server-side rendering here in the very first proposal. And if you're wondering why he cared about doing that, well, this was his hack to get people to actually use it. He knew that if he just published this proposal on its own, people around him would go, oh, that's a nice proposal, well done, Tim, and then they'd just completely ignore it. Have you ever had that experience happen to you in your workplace? Yeah? Pretty common. Now, he knew that would happen, so his hack was to take some information that people needed, the CERN phone book, and make it available in his system, so they would have to use it. Okay, but he didn't just write this proposal, he also wrote some software. He wrote the first web server and the first web browser to demonstrate how it could work. And I've got the code for both of those right here, so we can have a look and see where this all started. All right, so this is Berners-Lee's original web server. It's a C file. It's, how big is it? It's 730-something lines of code, written in October 1990. And the code quality in here, I mean, it's clearly a prototype, right? We've all done some pretty dubious things in our prototypes. and that's fine. It's just to explore the ideas. But the important thing about this is that it really works, okay? And we can still compile it and run it today. I had to make about, I think, maybe 3 small tweaks to the code, and then it actually compiled with a modern GCC compiler. So this compiles tcpserver.c to produce a binary called HTTP daemon. And you can see it's very tiny, under 22 kilobytes. And I can run it now directly on my machine. There we go. And you can see it says that it's listening on port 2784. That's a bit weird, isn't it? Why is it 27884? Shouldn't it be port 80? Well, we'll talk about that in a minute. Now, I can't connect to this from a normal web browser, or a modern web browser anyway, because this only speaks a very ancient dialect of HTTP, which modern browsers will not talk at all. So the only way we can connect to this really now is to do so by hand. I'm going to use Telnet. So if you know much about the HTTP protocol, you might imagine that you could do something like this, get and then / to get the home page. But that doesn't work, okay? I'm not entirely sure why, it just doesn't. But if you reverse engineer the source code a little bit, what you'll find is what you can do is you can type in the name of a file that is on disk, and it will serve that file to you. So the original web server is a static file server, which is something we still do today. So that's pretty understandable. But it's not just a static file server. It's also got a bunch of features that might be a little harder for us to understand. Like it's got this built-in find feature where it can search a set of disks, whatever that means in this case. So I'm not entirely sure what that's doing, but you know, it's exploring some ideas. And it's also where Berners-Lee introduces a beautiful tradition that continues to this day for all web servers, which is to have terrible security vulnerabilities. Okay? And he gives us a good example of how to do it right here on line 286. You can see here that it's calling out to the shell. This is a system command. It's like running a bash executable or whatever. And what is that system command? Well, it's just whatever has been entered by the user. So you can just send a request and it'll just run arbitrary stuff on the server, which is quite nice, you know, very generous of whoever runs the server there. And in terms of this port number, it started off as 2784, but a little while later in version 3, they changed it to port 80. That was allocated by someone else about 31 years ago. And that's when the team working on this really felt that they'd made it. And this old number, by the way, apparently was the last 4 digits of Berners-Lee's parents' phone number. So, yeah, don't know why he chose that, but there you go. All right, so that's the first web server. He also created his original idea of a web browser. I'm going to show you that. It's a bit more sophisticated, actually. So let's have a look at that in here. This is the Next Step operating system. Anyone ever use Next Step here? Wow, 2 or 3 people have. I did not expect that. All right. So Next Step. Next was a computer company run by run by Steve Jobs, who was kicked out of Apple. He went off to find this new computer company, Next, and they eventually went back to Apple later. But while Next was creating this, they did a lot of great innovation in the operating system world. And many of the features of Next you can still see today in Mac OS. For example, it's got the spinny beach ball thing whenever it's busy. It's also got this multi-column file browser, which you would recognize from macOS today. And inside here, I've got the source code for this web browser. And again, it can be compiled and it can be run today. So let's do that. So I've got this installed. And when that comes up, you'll see it's a little bit different to what we think of as a web browser today. First difference is every page you go to comes up in its own separate window that just kind of floats around independently. So a different idea of, different from the multi-tab setup that we have today. It's got some stuff that you might think that you understand, like this back, next, previous, and so on. I'm afraid you're mistaken. Those do not mean what you think they mean. They've changed their meanings over time. At this time, it meant something like go backwards and forwards through all the links in this page, which is a bit harder to understand. It's also got some stuff that you perhaps wouldn't have expected. Like, can you see here that it's got a check spelling option? So why would you want to check the spelling of a web page that you've gone to? That seems a bit strange, doesn't it? Well, actually, there's a great reason for it, which is that this is not just for viewing web pages. You can edit any web page you go to. Because remember, this is meant to be a sort of shared notebook thing. So of course you can just go and edit. You want to make sure you don't make any spelling mistakes. And it's got other cool, surprising things, like it's got this style picker. I can choose different styles. Even got this whole thing where you can design the styles that are in your document, and it's got all these built-in diagnostics as well. So it's kind of like early browser dev tools showing up there. So at the same time, this is really an alien kind of browser to us, but it's also got a load of ideas that we still recognize now. All right, so let's get out of there and move back into the slides. All right, so there was a little bit of a critical problem with this whole thing, with this prototype. So Berners-Lee had made this browser that works on Next computers, but no one else apart from Tim actually had a Next computer inside CERN. So it's kind of hard to see how this was going to catch on. But fortunately, someone came along to save the day. Nicola Pello was an intern at CERN at the time, and she could see what was going on and the fact that this had potential, but clearly not going to work if no one else can run the browser. Thankfully, she invented a way of rendering that hypertext to a plain text format that would run inside the terminal computers that people actually did have at the time. Very good job that that happened. If it didn't, I don't think we would be talking about the web today. But the fact that it did meant that this was able to catch on inside CERN. And in fact, they then made it available to the public through Usenet, and it caught on very quickly. A lot of people got very enthusiastic and started creating their own browsers. And we started to see a development towards browsers we know today. One of the most important and innovative ones was this one called Viola, or Viola, I don't know how to pronounce it, by Payway. And it has some of the UI patterns that we recognize now, like it's got the address bar at the top and the back and forward stuff that we know about. It also innovated it in some really impressive technical ways. For one thing, Payway came up with the idea of having this style sheet language inside the browser. Now, it's not CSS, obviously, that hadn't been invented yet, but you can kind of see where we're going here. Like, you can pretty much write that code yourself today. You could understand it just from the syntax. But even more impressively, he put in scripting. So the entire browser was written in this scripting language, and he allowed people to embed the same scripts inside their web pages to dynamically change the content. Not JavaScript, obviously, but again, it's setting a direction for what web pages would actually be. But people didn't really use this browser at scale because it was limited to Unix systems. They didn't all have that. The first browser that was cross-platform and was really used by a lot of people was this one, NCSA Mosaic. And I'm going to show it to you right now. OK, so I'm going to show this inside Windows 3.1. A little bit before my time, I'm pleased to say, but I think we can work out how to use it. OK, so here's Mosaic, and I'm going to start it up. Oh, no, I'm not, because we've got a terrible problem. What's this? Can't find WinSock? Well, this version of Windows is so old, it does not even have built-in support for TCP networking. So to enable that, you have to run this bizarre third-party thing called Trumpet WinSock, which is a lovely name. And once you've got that running, you can start up your browser, and it should actually work. OK, now, I can't connect this to the modern web, or I have actually tried. I've got it working on the internet, but modern web servers don't speak the version of HTTP that this wants to use. So the only way I can show you it doing something is to just open a local HTML file. So here we go. This is the original Mosaic homepage, which would have come up when you first install the browser. And you can see it pretty much resembles what a web page should be. It's got paragraphs, it's got unordered lists, it's got links. The links are blue. When I hover over it, the cursor turns into a little hand with the URL appearing at the bottom. So many things that we understand and recognize and expect today, all in here. But the biggest innovation, I think, something you might not have even noticed as we went past it, is this image up at the top. So this is an inline image, which was a big technical step forwards. Prior to this, browsers would only open images in external windows. But in this browser, the image can be inline in the page. And clearly, that's a very critical part of what web browsers need to be. So how did that come about? You might wonder, how was the image tag standardized? What was the standardization process at that time? Well, there were no standards bodies back then. In '93, all they had was a mailing list. And one day, a certain chap called Mark Andreessen, who we'll hear more about later, he was working on this Mosaic browser, and he said, I'd like to propose a new tag, and we're going to call it img, and it will have a required argument of circ. And he gives an example of that at the bottom, and if you're a web developer, you'll recognize that syntax. And immediately there was a reply that came back from Tony Johnson saying, oh yeah, I've already invented that exact same thing, except mine is different. And also, do we really have to call it img and circ? Can't we give it sensible names like image and source? And that's a pretty good question. I think we could probably all agree. Why didn't we do that? Unfortunately, nobody addressed this point whatsoever, because the next thing that happened was that Berners-Lee came along to weigh in, and he said, no, this is all completely wrong. We can't do it like that. We're not going to have img. An image should obviously be represented as an A tag with rel equals embed or present, because that's much more intuitive. Developers are going to like that. They had a little bit of a debate that went on for a few days. Berners-Lee was really saying, the A tag would be much more appropriate for this use case, but he also made a little bit of a tactical blunder, because he said, in any case, we can't change HTML because it's going through a standardization process right now, so we just can't change it. You can't do a new thing right now, sorry. And that gave Andreessen the opportunity to just have his own way, because he came back then and said, oh, Tim, I absolutely agree with you in all cases, which is why I'm going to completely ignore your position on this subject and do what I want anyway, because I can't wait for your standardization process. I'm doing real-world work here. And then he went on to say, yeah, we're definitely going with img and circ, because I wasn't really asking your permission. I was just telling you this was all pointless. OK, so that's how the standardization went down at that time. I don't know if Berners-Lee felt burned at all by that, but coincidentally, the following year, he founded the W3C, an organization that has a kind of moral authority to tell browser makers what they should do and what standards they should follow. And this was part of a period of very rapid growth for the web. Like by now, there were literally thousands of websites, which is absurdly small, but it was growing at a rate of about a factor of 10 every single year between about 94 and 99 or something like that. So many orders of magnitude of growth during the rest of that decade. It's incredible growth. And it's when some of the big companies and big brands that we know started to get in on it. So the first one to mention, it wasn't a big company originally, actually, Netscape. Netscape was a startup. And it was our friend Mark Andreessen again. So he finished working on Mosaic, and he went to work with someone else, and they set up a startup. And they were not planning to make a browser at all. They were going to make a gaming network for the Nintendo 64 console. That was their plan. But Nintendo was taking too long to release this console, and so they said, oh, what are we going to do? We can't wait anymore. Shall we come up with something else? I don't know. Shall we just, make another browser or something like that? So they did, and that's how Netscape came to be doing what it was doing. And that went on to IPO the following year for a lot of money, and that started the dot-com bubble. It also attracted the attention of some of the big players. You might have heard of a certain Microsoft who came into the market the following year. They licensed the NCSA Mosaic source code. They wrapped it in some Windowsy stuff, and they released that as Internet Explorer 1. And that started the first browser wars between Netscape and IE. As you might know, IE went on to win that pretty conclusively. It got, I don't know, it was 96% market share or something by 2001. So in a sense, that was a huge success, but it also caused some pretty serious legal troubles for the company. But that's how that went along. But let's stop talking about browsers for a little bit. Let's talk now about the people writing the code that was implementing actual web applications. So how would you write a web application at this time? Well, you could just write HTML by hand in Notepad or something like that, or you could use something like Perl scripts and CGI bin and other very low-tech solutions to connect code to your web server. But then someone came along, Rasmus Lerdorf, saying, wouldn't it be better if we had a dedicated language for generating web pages? And he released the personal homepage tools to help people do that. Now, the syntax is completely different these days, but the original syntax was this, like HTML comments that embedded code. And it had some cool and useful features, like you can see it can connect to a database there about halfway down. It's doing a SQL query, which is powerful and useful. And yes, of course, it has a SQL injection vulnerability. I know, we can see that. It had to, right? That was the way of things. That was the culture at the time. You had to have SQL injection vulnerabilities, or you were just not, playing the game in the way that you should do. All right, so that was early PHP. Rasmus was not completely confident in what he was doing, it seems. When he was asked a bit later, he was like, I'm not really sure what I was doing here. But we have to acknowledge that this has been one of the most successful web technologies there's ever been. Despite all this, You know, much of the early web was built with it. Facebook used it at scale. Very, very successful technology, despite just how sort of, you know, pragmatic the approach was to creating it. All right. Now that brings us into the world of the front end. We haven't mentioned that yet. I think we could say 96 was the year when front end was born, because that's when JavaScript was invented and CSS and two of the big consumer-facing web page creation technologies. I'm going to show you one of those right now. I'm going to show you front page. Okay? So let's imagine that it's 96, 97. You've just heard about this .com bubble, and you want to get yourself very, very rich. Okay? So I'm going to open up this copy of Windows XP. Okay, no, Windows 95, in fact. We're web developers in about 96. We're probably going to be running Windows 95, and we've just installed Microsoft Front Page. So let's see what the experience of creating a web application would be like back then. Okay, well, I don't really know what I'm doing, so I'm going to create it from a wizard or template. Okay, what are we going to do? Well, the goal is to get rich, right? So we're going to create a corporate presence, I think, and we'll call it, I don't know, we'll call it Steve Corp. It sounds like a good name to me. All right. So what's it going to do? Well, it's going to ask us a few questions about this site that we want to create right now. Like, what do we want to have on it? I don't know, more stuff. Oh, yeah, let's have a mission statement, because it's very 90s. And then it's going to ask us more stuff. And it just keeps going on and on and on with so many questions. And eventually, it lets us finish the wizard, and it's going to create this website for us. Now, Microsoft at the time, they knew that people didn't know how to create web pages. So one of the features in here was this cool thing where it teaches you what to do. It gives you all the steps needed to create your web page and allows you to assign tasks and things like that. It also gives you this nice graphical overview of your site and all the links in it. And you can double-click on a page and you can get into the editor. Right, now, in terms of the graphic design here, remember this is meant to be the corporate website, okay? So I'm not completely sure what was going on in the minds of the people in Redmond at that time. But, you know, you could come in here and you can start typing out your web page content and stuff. But the more impressive thing was, it's got some really powerful features, such as the ability to add script. And you can write script in the new JavaScript that's just been invented, or VB script, and with the simple click of a checkbox, you can make that script run on your server as well. So it's very, very powerful, dangerously powerful, and this was the classic ASP phase of web development, where people could write VB and it would just run some code on the server. It gets us into a little bit of trouble as well, which we'll mention in a minute, but let's get out of here. No, I don't need to save that. All right. Okay, so what about JavaScript and CSS? Well, you might have heard a story about how JavaScript was created in 10 days. Well, apparently it's true. So Brendan Eich, he got hired to work at Netscape when they were working towards Netscape 2. And his boss was Mark Andreessen, who we've heard of. Okay, and Andreessen came to him and said, hey, Brendan, in about 10 days, we're going to be having an all-hands meeting, and we're looking for some cool demos. Wondered if you could do something like, I don't know, could you create a demo of something like a programming language that works inside a web page? It doesn't have to be very good. Obviously, it's just a demo. No one's actually going to use it. Just do whatever you want, basically. Do you think you can do it? And Brendan Eich took on the challenge, and he made... Oh, has my sound gone strange? OK. Am I back to normal? Yeah? All right, good. So Brendan Eich took on this challenge, and he worked very hard for 10 days, and he did create something that could run inside a web browser. And the design directions that he was given at the beginning there have influenced JavaScript all the way up to the present day. For example, Andreessen told him that this can't be a compiled language because he wanted people to be able to just type the code straight into their HTML files. So it has to be just some text that human beings type out. And that decision has stuck with us all the way through the history of the web, at least up until we got up to WebAssembly. That's the first time we got away from that particular design decision. And then CSS. Well, JavaScript was created sort of unilaterally by one corporation, Netscape, but CSS was not. CSS was a community effort from the beginning. All the enthusiasts of the web at that time were talking to each other over mailing lists and so on, and discussing how could we create some sort of style sheet language. Because, you know, we've seen this work in the past, even like Viola browser had this. What should it look like? And there was a bit of a design competition, which was ultimately won by this design by Håkon William Lee. And I know it doesn't look much like CSS today, it doesn't have curly braces, but it did set much of the design's idea, much of the terminology was determined in this original thing. And Håkon went on to work with someone else, and they actually made this what we know today. Browsers were very slow to actually adopt it, but eventually they did. All right, let's talk about accessibility for a minute. That's a thing that we can't afford to miss, because if we do, it's going to burn us later. All right, so accessibility has been a legal requirement for web developers to think about since the first instant that the web was created, because existing legislation already talked about the need to account for accessibility across all products and services. So as soon as the web was invented, it had to care about this. Berners-Lee knew about this. He wrote a message to the W3C newsletter in '96 saying, hey guys, what about accessibility? Like, what should we do? What's the good practices? What technologies do we need to create to make this work? It started a conversation which ended up with a meeting at the US White House, I heard, involving some US congressperson, and during that they founded the Web Accessibility Initiative. And that gave the US legislature confidence to make that part of their updated Section 508 guidance that came out the following year. So that made it very clear that the web was absolutely subject to this accessibility law. And so to help developers make a good job of that, the Web Accessibility Initiative created these content guidelines, the Web Content Accessibility Guidelines, the following year. They did some updates, and then many different jurisdictions included that in their law. For example, the EU in 2016 said, well, basically, you've got to do what the version 2 of these guidelines said. And there was a further update a little bit later. And the main thing I want you to take away and understand from all this is a little bit of a sense of gratitude that this was done in the way it was. Because imagine if these guidelines were not created when they were. What would have happened instead is we'd have had 200 countries coming up with 200 different sets of rules about what web accessibility would be like, and they would all be written by people who didn't even understand the web, and you would have to know about and comply with all that. But because these rules came out early enough, and they were written by people who understand the web, we've got a fairly consistent set of rules to follow globally, and that's something we can actually do, so that's nice. All right, now let's get back into some programming languages. So there was a bit of a problem. Microsoft was really getting into this whole web thing around 2000. And of course, Microsoft had already got this classic ASP thing, but it was slightly problematic. People were writing very messy code with it, insecure code, but the worst problem was it was not object-oriented. And in 2000, everything had to be object-oriented. That was the law. Okay? And then second point was there was this very successful technology called Windows Forms, which had this beautiful graphic designer. Why can't we have something like that for the web? So someone you might have heard of, Scott Guthrie, just started working at Microsoft, and his manager, Mark Anders, was set the job of coming up with a solution for this. So this is apparently the notebook they used when they were designing the original ASP.NET. And I'm going to show you what that looked like in the beginning right now. All right, so it's 2000, 2002 maybe. You're a web developer, and you've just installed the Microsoft Visual Studio.NET, the first release of .NET, which also has got ASP.NET in it. So let's start that up. And it's pretty fast, right? So that came up kind of instantly. I'm slightly cheating here by using hardware from 20 years in the future, obviously. We still recommend that today if you can for Visual Studio. All right, so I'm going to create a new project right now. All right. And what will I call it? I don't really care what it's called. But when that's created, you'll see the first thing that comes up is this visual designer. We don't really have those these days, but let's see how that goes. All right, so I'm going to put some stuff in there. Hey, and I've got to use the actual keys that correspond to what I want to type. There we go. Right, and then I'm going to use a button as well, and we can do some really high-end graphic design as well. So I'm going to give that a nice sort of peach background color. That's cool. Let's see what kind of markup we're actually creating here. It's surprisingly not that bad. Okay, so we've got a form with a label and a button. That kind of makes sense. There's some bits about this that I don't know what they are, and I don't even want to know what they are. Like, what is that? I don't know. Probably evil. Let's just pretend we don't see it, okay? I'm going to press Control F5 now, and it's going to open up this thing in my browser. All right, I can click the button. Nothing happens because I didn't add any behavior. But adding behavior is really, really nice. So I double click on the button and I can start typing out some behavior. So I'm going to say that when I do click on it, I want the button 1 text to change, and it will become you clicked at date time dot now. So I'm using the brand new C# programming language there. And when I click that, the text on the button does change each time I click it. All right, now how does that work? Because we've got this kind of stateful interactive behavior, even though the web is stateless. This is not using JavaScript, because at this time, JavaScript is just this ridiculous toy language that you can't really do anything with. So how does it actually do it? Well, there is a way we can kind of see what's going on. If I use the back button, notice that I'm able to travel backwards and forwards through time. That's pretty bizarre, isn't it? It's kind of advanced. We don't even do that with modern web tech, so how is that working? Well, it's working like this. If I go and view the page source, it's generating this thing called viewState, a hidden field which contains this huge base64 blob that represents the whole state of the UI. And every time I click that button, it's sending that to the server, it decodes it to get the state of the UI, it runs my event handler, updates the UI, reserializes it all back out as HTML and viewState again. So it's a pretty clever solution to the problem of statefulness on the web. And it does run into a few problems, but you know, it's a pretty good thing at that time. And in fact, a lot of people at that time might think that this is it, you know? We've reached the pinnacle of web programming. It's object-oriented, there's a designer. It cannot get any better than this. But some people had different ideas. And one of the biggest things that changed how people thought about web development at that time was something that landed a couple of years later, Rails. We've got to talk about Ruby on Rails, okay? So David Heinemeier Hansson, DHH. He's a bit of a controversial figure these days, but at that time, he was just a poor, humble hipster web developer who decided that none of the existing programming languages were good enough for what he was doing, so he had to go out on this spiritual quest to find an artisanal, handcrafted scripting language from Japan that no one else had heard about in order to create his product. And he found Ruby, which wasn't much known of by anyone outside Japan at that time. And he built an application with it called Basecamp, which was pretty commercially successful. And from his experience there, he extracted a framework and he published it as open source. And it made a really big impact because it brought loads of new ideas, absolutely loads. It was kind of amazing, really, how much new stuff came in this all at once. So I'm going to show you. All right, right here, I've got Rails version 1.0, which is not the very first ever release of Rails, but it's the oldest one that I could make work. And I'm going to use it to create a blog, and we'll see what the programming experience is like. First new thing here is, notice I didn't use an IDE or a wizard to create this, I just used the command line. All right, so that was quite interesting. Now I'm going to start this running. So I'm going to run the server script. That's also a little bit new. I didn't install a web server onto my computer, I just ran this script. Let's see what it actually does, shall we? So over here it says, hey, you're riding the Rails. Very exciting. We're getting started. And it gives us some startup steps, like start by defining what your database is going to be in this file. Okay, so we'll do that. I'll go over to the database config and I'll say I want it to use SQLite 3. All right, now this is a YAML file, which is yet another new thing as far as web developers are concerned at that time. And again, another new thing, I'm going to create some code now using a generator. So I'm going to use the command line to generate myself a controller called blog with an index action on it. All right, so that's generated a bunch of stuff. And if we look over here, we can start to see the architecture of this thing. We've got models, views, and controllers. So it's MVC. Now, DHH didn't invent MVC, but he was probably the main person who popularized it for server-side web programming. And we can see how this pattern influenced many different phases of web development later. All right, so we've got this controller we've just created. How are we going to get to it in our web browser? Well, another new idea that was brought in here was this convention over configuration approach. We don't have to configure our router, it just follows conventions based on the names of our files. All right, now let's make this do something. I'm going to need to have a model. So I'm going to generate a model for a post in the blog. All right, and it's generated not only that, but also some automated test code. Again, yet another thing that developers were not expecting at that time. And now I can generate some UI for that. So I'm going to say I want to scaffold a UI for the thing that's called post, like that. All right. So again, another new thing here, because developers did not expect the system to generate the UI for them. Got a bit of a problem, which is it's trying to read from my database, and I don't yet have a table in my database for these posts. So we'll create one, and we'll do that using another new concept, a migration. So migration, a way of defining in code changes to your database schema. So I'll create one for the posts table, like that. And then that's going to generate this file here, and I can write in some logic to control what's going to be in that table. I'll have a title and a body. All right, so to run that, I'm going to run rake migrate, like that. That updates my local database schema. Then I'll start up the server one more time, run that again, and we've got actual working UI now. So I can have this is cool, and it actually works, and it saves content in the database. We've got an MVC architecture, we've got automated tests, we've got command line tools. You can see how incredibly different this development experience was to what we just did 5 minutes ago in Visual Studio and web forms. Hugely, hugely different and very influential. And we'll see how it goes on to influence different aspects of JavaScript in the future. So let's start thinking about JavaScript a bit more now and front-end development. I think that JavaScript was kind of reborn between the years of about 2005 and 2008. Prior to that, people weren't really taking it seriously, but as of about 2005, there were commercial pressure that forced people to take it seriously. And that was mainly to do with the Web 2.0 wave. So Web 2.0, it's a funny name, but basically that was the time when companies realized that they could extract a lot of commercial value from user-generated content. So loads of sites started springing up in which it was all about users submitting content and then communicating with each other. And if you're a user, which sites are you going to spend your precious time creating content for? Well, among other things, it's going to be the ones that have got a nice UI that make it fun, friendly, and quick to make some nice content in there. So there was a lot of pressure to create the best UIs. And some of the best work in this area was done by Google. And they brought out this thing, Google Maps, which at the time was absolutely mind-blowing. I remember I was a new web developer at this time, and when I saw Google Maps for the first time, the fact that you could drag this map around, you could zoom in and out, and it wasn't reloading the page, it was just absolutely mind-blowing. And developers across the whole world just absolutely lost their minds over this, because we did not know that you could do that sort of thing. And everyone wanted to create user interfaces that were as slick as that. But no one really knew how to do it. Everyone was sort of coming up with their own techniques. But after a little while, one thing started to stick, and it was thanks to this blog post by Jesse James Garrett, who came up with this terminology of AJAX, asynchronous JavaScript and XML. And he said, well, let's look at what Google's doing, okay? Let's start to extract some principles about what their UX patterns are there. And more than that, let's try and understand some of the technology that they're using behind it. And he came up with words with patterns and terminology to describe this. And some of it was right and some of it wasn't quite right. You know, some of it didn't stand the test of time. For example, he talked a lot about XML and he talked about this thing called engines, which is not a thing we talk about these days. But one fundamental thing he did get right was this idea of making requests in the background to a server while the page was there and updating the DOM dynamically. That obviously stuck with us, and that seems like a basic and obvious thing today, but it wasn't basic or obvious at the time. And one other thing that really helped that to catch on was the arrival of this library jQuery, which I'm sure most of you have heard of, most of you probably still use today, and that allows people to simplify the big mess of DOM code to something much smaller. And it was very, very successful. It was the first ultra mega successful JavaScript library. At one point, it was used by nearly 70% of all websites. And if you look at where that peak is on the timeline, it's only just started coming down. So it's amazingly successful. So think about it now. You're a web developer, you're writing a lot of JavaScript by now, but how are you going to debug it? What's the state of browser dev tools at that time? Okay, well, let's have a look, shall we? We'll go back into this browser, Internet Explorer 6, and we'll open the browser dev tools menu, which is in here. No, it isn't in here because there are no browser dev tools at this time. The closest that you can get to dev tools right now is open the source in Notepad. That's it. You know, that's what you've got and you're gonna like it. Now, not everybody felt that way. all right? There was one person called Joe Hewitt who had previously been one of the engineers on Firefox. He left Mozilla and he went to start his own thing. He started creating he created web applications. And while he was creating web applications, he started to realize, this is a pain, right? There's no debugging tools. Can I do something about that? So he and a small community created a browser extension for Firefox called Firebug. Let me show you what that looks like, because you're going to recognize a lot of this. Right, this is an old version of Firefox. It's version 2. And inside it, I've got the Firebug extension installed. And that gives this inspector with a console, HTML view, CSS, it's got a script debugger, it's got network trace, really, really familiar stuff. Pretty much the same UI design that is used today in browser dev tools. So this was very popular. It caught on very quickly. A lot of web developers started using it, and even it started to get copied and integrated into Firefox itself. It was also fairly well copied by Google. So this was Chrome version 1.0 that came out around that time. Very, very old version of Chrome, but it still works with the modern Google website. And we can go to inspect element in there, and you can see this is their first browser dev tools. It doesn't really have as much stuff in it as Firebug does, but they started to copy more and more of the stuff over time. All right. So now people could start to write quite a lot of JavaScript, and that set the stage for JavaScript escaping from the browser and getting onto the server as well. Node.js. So Ryan Dahl, he was a Rails developer, and he was very influenced by these Web 2.0 style user interfaces where things would update all the time in the background. He loved that, and he wanted to do that. But the problem was his web server couldn't handle more than one thing at a time. He wanted to make Rails do multiple things at a time, and his first idea was to use multi-threading, but it didn't work because Rails wasn't multi-threaded. Ruby itself didn't handle that, and nor did Python, the other thing he tried. But then he had a brainwave. JavaScript, another scripting language, is not multi-threaded either, but it handles concurrency using an event loop. And it just so happens at the same time that Google open sourced their V8 JavaScript engine. And so he says that it was obvious to him that he should create a web server based on V8 that used an event loop for concurrency. Now, it doesn't seem obvious to me, but he thought it was obvious, so he did. He quit his job, he spent 6 months working on this, and then he released it at a conference, and it was obviously a huge influence on the web to this day. Okay? But JavaScript was not finished yet. JavaScript is a monster that wants to eat everything. And it's not enough just for people to write small web applications or server-side applications. It needs big applications as well. That brings us into SPA frameworks. JavaScript had another little rebirth. But when this book came out, people started to realize there was actually quite a decent language hidden inside JavaScript somewhere. And people wanted to use it to build bigger and bigger applications. This slide here represents the connections and the inspirations between different JavaScript frameworks. Now, I did not create this slide. I have stolen it from Sarah Drasner. She's a director of engineering at Google, and she's one of the most authoritative people in the world on this subject because not only does she run the team that has Angular in it, she's also on the Vue core team and was a keynote speaker at ReactConf, so really knows how this stuff goes together. And I absolutely can relate to and appreciate all of these different arrows. It makes sense to me. And I want to focus on this first wave here that came out in 2010, because a load of people started doing the same thing all at the same time. The time was right for it. The first one of these frameworks to be publicly released was Backbone, which did a Hacker News post on October 13th of 2010. And then exactly 1 week later, Knockout, that was my project, that did a Hacker News post exactly 7 days later. And it just so happens that on the very same day, AngularJS did its first public release as well. Now, Angular had existed for a while inside Google, but it was private. It only went public on that particular day. So there was no coordination among these things. It was just a time that the world was ready for this, and it had to happen. A bunch of people did it at the same time. So I'm going to show you an example, and in honor of the fact that Backbone got the first release out, I'm going to show you a Backbone application. So you can see how this would work. So the core thing here is JavaScript developers were exceeding the boundaries of what could be done with jQuery. The applications were getting too messy with just big bundles of event handlers. But people knew that it could be done better because they'd seen Rails, for example. They knew that things like model view controller architecture was possible. So could we do that for browser-side code as well? And that's what Backbone was all about. So here we've got this simple example. I didn't create this. I'm just going to show you the UI running. So let's get that open. It's just a to-do list. You know, we've all seen that sort of thing before. We can add stuff. We can mark it as done or not. But the important thing is how it's structured. So we've got a model, we've got views, and we've got a controller-ish sort of thing. Now, MVC is a bit weird because everyone knows what models and views are, but no one really agrees what controllers are. It's just whatever is needed to make models and views work together. That's really the core important thing, is this model-view separation. That's the core of the pattern. And the way it's done inside Backbone is like this. So we've got a model for our to-dos and one for the to-do lists. We've got a way of calculating data based on what's in the model, you know, like how much stuff is done or remaining. And then to represent that as a UI, Backbone uses the underscore templating engine. Now, underscore is a JavaScript library created by Jeremy Ashkenas, who was a developer. I think he was working at the New York Times at the time. And Ashkenas created underscore. He also created Backbone, which we're looking at now. And then he went on to create CoffeeScript, which we will mention in a minute, because that was very influential too. So Ashkenas had a big impact on the web around this time. And the way that Backbone is rendering its views is like this. So it's got this render method, and you use it to create some HTML from the model. And then finally, we've got this controller that binds various events inside the browser so that they will update the model, and in turn that re-renders the view. So that's some basic MVC stuff in the browser. And like I said, many different people started doing this at the same time. It caught on very quickly. All these libraries were used at pretty high scale, and most of them stuck with us to this day, or at least newer versions of them did. And we'll talk about what that ultimately evolves into in a few minutes. All right, so during this time, we are now in a period of very, very rapid expansion of complexity. People are not just exceeding the boundaries of what jQuery can do, they're exceeding the boundaries of what all these MVC frameworks can do as well. Our applications are becoming so big, we don't just need a new framework, we now need a new language to help people to write code at a higher scale, and that's where TypeScript came along. TypeScript compiles to JavaScript, as you may well know. It wasn't the first language to do that. CoffeeScript, I don't know if CoffeeScript was actually the first, but it was certainly the first one that really caught on and got a lot of people to understand that that was an interesting way to create a language. And TypeScript followed on from that. So Anders Hejlsberg, creator of C#, and various other people inside Microsoft got together and said, well, thanks for the inspiration, Ashkenas. How about we use a similar technique, but now we'll use some modern type theory and everything we know from C# and so on to create a really nice type system for JavaScript. And that was very, very successful. That went from 0 users 10 years ago to being something like the second most popular programming language in the world today. So incredible growth of popularity, really required. And the fact that we now need to compile gives rise to other parts of the toolchain. For example, Webpack is a build and bundling system which is needed because people are now, compiling from TypeScript, they're processing Sass and less and bundling, all kinds of stuff. Like, it's complicated, right? You're dealing with this sort of stuff all the time. Webpack was there for that. And I've thrown in Kubernetes as well, mainly just to try and completely mentally exhaust you, because I want you to appreciate that, seriously, this is so much stuff going on right now. As a web developer, you don't just need to know client-side stuff, server-side stuff, special languages, build systems, all that. You've got to understand cloud orchestration as well. And isn't it enough? Don't I do enough? And yes, it's a lot, okay? Maybe it's exceeding the limits of what individual developers can be expected to understand. And maybe some sort of pushback might need to start happening, and we'll talk about that in a minute. All right, one last thing before we get to that, though. Another technology came on the scene a couple of years later, which has had a big impact. It's important to me, at least. WebAssembly. This was the first place where we got away from Andreessen's design direction to say you just have to be able to type out the code. Okay, so this is what we say. If we imagine we can compile from any language, any platform, to some kind of bytecode that we're running in a browser, well, that's what WebAssembly is all about. That was a joint project from Mozilla, Google, Microsoft, and some WebKit developers at Apple. And that has enabled various new kinds of technologies to get into a browser. Now, do you know what the absolute best thing is that you can do with WebAssembly? Well, I've got an opinion about that, and I'm going to show you an example of it right now, which is running .NET inside a browser. So, just as an example of WebAssembly, for no other reason or agenda at all, I'm going to give you the original Blazor prototype. All right, so Blazor is a way of running .NET, or it was at that time, a way of running .NET code inside a browser. It's come on a long way since then. And this was the original prototype. If you've used any Blazor, you might recognize this particular project template, because embarrassingly, we still haven't changed it after all these years. And I keep saying every year, can we please change it now? And we haven't done yet. But the important thing is that it's, I better get back to the home page and reload. Right, so it's getting some .NET DLLs here, regular .NET assemblies that have been compiled with a normal C# compiler, and running them in the browser thanks to WebAssembly. We've got this runtime, dna.wasm. DNA.NET Anywhere, that's not the regular .NET runtime. It's a very small .NET runtime created by one person called Chris Bacon, and that compiles very easily to WebAssembly to produce this tiny 52 kilobyte file that can run .NET code inside the browser. So that was enabled by the fact that this WebAssembly tooling came along, and many other things have been enabled too. Just a couple of days ago, Flutter announced that they were going to get Dart running inside a browser on WebAssembly as well, so we see more and more movement in that direction. Okay, right, we're running low on time. So what about this decade that we're in now? I'm not going to talk too much about stuff that's happened over the last couple of years, because the dust hasn't really settled yet. We don't know what's going to turn out to be important and what isn't, but I do want to pick out a few trends that I think are interesting and might set a bit of direction for where things are going. One of them is that, yes, things are too complicated. We're asking developers to deal with so many different things. Could we simplify that a little bit by bringing some of the complexity as native features in the browser? So we've got some proposals and specs that change things a little bit. For example, HTTP 2 and 3, they mean that it's now just as efficient to send lots of small files to the browser as it is to bundle and send one big file. So that simplifies a bit of the build process, potentially. The type erasure proposal, that would allow browsers to run languages like TypeScript without needing to be compiled first, just by teaching them to ignore the parts of the syntax that they don't understand. And then finally, CSS nesting, that allows you to get much of the benefits that you do with things like less and Sass, but without having to pre-process it. So you can just nest all your selectors together and get a better syntax. And it just so happens that last week, the Chromium project announced that they were definitely going ahead with CSS nesting. So that's nice to see. Another way in which things might get simplified a little bit is with more of JavaScript taking over things, or with this time with single-page application frameworks taking over not just what happens inside the browser, but the server as well, and integrating that stuff together. So you don't have to deal with two different programming styles, and you don't necessarily have to deal with as much build stuff because they integrate it all together. And I'm going to show you an example of that in a second. And finally, I just wanted to mention, it's a little bit separate, but one of the complexities we deal with is thinking about where we deploy our sites and whether the servers are up or down and so on. One way we could mitigate that is if instead of deploying to just a few locations, we deployed to thousands or tens or hundreds of thousands of locations at the cloud edge. And that way, we don't really have to make decisions about where stuff gets deployed. All the users get very low latency, and you pretty much can't be down unless the whole global internet is down. So that's one of the things that might help us a little bit. But let's get back to this thing with SPA and metaframeworks. So next, Astro, SvelteKit, SolidStart, and others. These are metaframeworks. JavaScript developers are dealing with so many frameworks now. You need a framework to manage your frameworks, and that's what a metaframework kind of is. But it's also about having something that spans server, client, build, and deployment. I'm going to give you an example now of SvelteKit, because it's got a bunch of new and fun ideas in it. Okay, so I've created this project here using the SvelteKit template. It doesn't really have anything in it just yet. It's just this sort of hello page. Okay, and let's have a look at some of the code in here. Well, we've got a page.svelte file, which has just got some markup in it. And of course, it's got some basic features that we all expect today, like hot reload. So if I press save, you know it's going to update in the browser. That's to be expected. But slightly more usefully, it also bundles things like styles as well. So we don't have to worry about how styles are actually deployed or how they get into the browser. We just add some style wherever we feel like it, and it's going to appear suitably in the browser. So that simplifies stuff a little bit. But to show you more interesting features, I'll have to add a bit more functionality. So I'm going to create a counter. Everyone loves counter examples. It's sort of the hello world of SPA programming. So I'm going to create a new page that's got the very special magic name of page.svelte, with a plus sign. And that is part of Svelte's approach to convention over configuration. They've got this convention, which is that if you call a file this, then it's just going to show up. So it's kind of using some of the ideas from Rails there. And you can see it's also got built-in support for TypeScript. So this is fully typed data. And I've got my initial count. I'm displaying it. I've got a button. When you click it, it's going to update that count. All right. So if I come back over here, and if I want to get to that, I just follow the convention, like I said, and I end up on the right place, and then I can click this button and it works, all right? Nothing particularly special or impressive just yet, but let's start thinking about how we can span server and client. And to do that, I'm going to factor out a little bit of the logic here. I want to factor out the logic that decides what the data is and any other data loading logic. So I'm going to create a new file here called page.ts. And you can think of that as being a kind of code behind file. So it's sort of taking a bit of inspiration from web forms, I suppose you could say there. And inside there, I'm going to add some content here. I'm going to define the initial count now as being 1, 2, 3. And don't really need that line. So let's get rid of that. OK, and I've got a load function which is exported, and that's going to return it. So I'm not doing anything really different here other than just factoring some stuff out. I just want to use that factored out code here inside my UI. All right, so it's still all running inside the browser, but now the initial count is 1, 2, 3 instead of 0, and it goes up from there. But this change that I make is getting lost. Every time I reload the page, it's lost, and every user has got their own separate count. Could we create a globally shared count by having the count state live on the server instead, without having to change too much code? Well, yes, we can. One very interesting thing that we can do with a meta framework like this is I can simply rename this file to page.server.ts. And just by making that file name change, that file will now execute server-side rather than client-side. So whenever the user navigates to this page, it will actually make an HTTP call to the server to get the result back from this load function. So now we can control the data loading on the server. That's good. But you'll notice that when I reload, it still loses the changes. That's because when we mutate the state, we're just mutating it inside the browser's memory. Let's say that we want to mutate it on the server instead. So we want to expose an API endpoint that we can call. We can do it really easily by simply exporting something called actions. And now we've got an endpoint that we can call from the browser to increment that count. All right? So to actually call that on the server, I don't want a button that just mutates stuff in browser memory. I'm going to use an HTML form that will post to the increment action on the server. Okay, I know I'm doing a lot of stuff very quickly, but hopefully you can get the idea that we've got a form, you post it to this endpoint on the server, it mutates the count, and then the load state will go back down to the browser. Okay? So now when I click this, you'll see when I reload, I don't lose my changes. And in fact, if there are other users in other browsers, they would also be sharing the same count. How is this actually working, though, on the wire? Well, if we look at it, you'll see every time I click this, if you look at the browser dev tools, it's fully reloading the entire page. So we're doing a post to the server and regenerating the page on the server, which means we've kind of reinvented web forms again now. So that's all coming back. And that's kind of useful if you want to support users who don't have JavaScript enabled. Excuse me. But this user does have JavaScript enabled. So could we make things even better for them? Well, yes, we can. I can go to this form here, and I can put this magic tag on it saying use enhance. Okay? And when I've done that, what it's going to do is, that's not the one I want. What I want is, come on, tooling, you can wake up. No, tooling won't wake up. There we go. Right. So what that's going to do now is that if the browser has JavaScript enabled, it won't do a full page load anymore. It's not refreshing the page. It's just sending a message to the server to say, hey, I want to call this endpoint. Tell me how the UI should update. And then it's doing client-side rendering from there on. So now we've mixed server-side logic and client-side logic, and we're doing either server-side rendering or client-side rendering, depending on what this particular client supports. And in terms of all the build and bundling stuff, that's all baked in there as well. So in many ways, this sort of meta framework can simplify things and reduce some of the things that developers have to deal with. If you're wondering what that means if you're a .NET developer, well, we've got similar stuff in the pipeline in .NET 8 as well. Okay, so that is the end of what we've had time for. The web has come on a long way since Berners-Lee's original proposal. I'm not sure if he quite understood what he was unleashing on the world when he wrote this document. The thought I want to leave you with as you go out into the rest of the conference is think about how the decisions were made and who made the decisions along the way. In a few cases, it was major corporations who made decisions, but in a lot of cases, it was actually individual engineers. So think about Nicola Pello deciding to create a line mode browser. Think about Joe Hewitt, who decided that existing browser dev tooling was good enough. Or think about Ryan Dahl, who came up with this idea of having a JavaScript-based event loop web server. Just individual engineers who had a bit of inspiration and made it happen. And right now, you are those engineers. You're at this conference, you're talking to each other, you're sharing your ideas, and you are hopefully going to come up with some of the next wave in web technology. So I'm very excited to see what you come up with and hopefully be part of it. So go and enjoy the rest of the day and the rest of the conference. And yeah, that's all from me. Thank you very much.